Alright, in this video we're going to start talking about how to find vertical asymptotes for trig functions like tangent and secant and cotangent and cosecant in general. So it's really, relatively speaking, not a terribly difficult process, but I do think it's sort of important enough to get its own separate video. So we'll talk about how to do it with these types of functions here, we'll do a few examples, and then after that we'll talk about how to graph stuff like this more generally. So we'll kind of use this process to do the graphing process in general. But for now, let's just talk about the asymptotes. So example 1, find the general equation for the vertical asymptotes of y equals 2 times the tangent of 1/3 x plus pi over 2 minus 6. And then find 5 specific equations of vertical asymptotes. Okay? So what we're going to do is get the general equation, which is actually not really that difficult, especially for this type of function here. It's going to work out pretty nice, we'll see. And then we're going to use the general equation to get 5 specific equations. Okay? So let's go ahead and just jump right in and do it. So whether we have a tangent, a cotangent, a secant, or a cosecant, the process will be the same. The equations that we use along the way they kind of depend on which function we have, so they might be a little bit different, but the process is always the same. Okay, so what we do first is say, so what we're going to do in this video, we're going to talk about the process and then explain it as we go along the way, and then in the next few videos we'll just do the examples without really explaining the steps as much. So what we do first is we say original, as in the original vertical asymptotes. Okay, so what are we dealing with? We're dealing with a tangent function. So what we do is we write the equations of the vertical asymptotes for the original tangent function. Okay, so this would be x equals the quantity 2k plus 1 times pi over 2, where k is any integer. Okay. Now we've talked about this in a couple videos at least. So in the video where we talk about the properties of the tangent function, we know from that video that these are the equations of the vertical asymptotes. Okay, this is the general equation of the vertical asymptotes. Because remember, tangent is sine divided by cosine, and the cosine function equals 0 at these specific points. Okay, odd integer multiples of pi over 2. Because k is any integer, then 2k is always even because you multiply it by 2. Multiply k by 2, you have an even number. Add 1 to an even number, you have an odd number. Odd multiples of pi over 2, that gives you a value of x that makes cosine of x equal to 0. If cosine is 0, then the denominator of tangent is 0, so then tangent is undefined, so it has a vertical asymptote. Okay, so we talked a lot about that in a separate video, so we won't go through the details again here. But anyway, so that's what we have originally. So actually, when we do this type of problem here, it's better to use this in a different form. Okay, so first of all, we're going to stop writing k is any integer. We're going to stop writing that because it's sort of implied, and we don't want to take up all that space writing that over and over. So, but what we want to do is write this in a more useful form. Okay, so let's distribute the pi over 2. So if we distribute the pi over 2, we're going to get x equals, let's come down here, right, with what that would be. So if we distribute the pi over 2, 2k plus 1 times pi over 2 is going to be 2k times pi over 2 plus 1 times pi over 2. Okay, so distribute that pi over 2. Now these 2's cancel, that's great. And then what we're left with is k pi plus, and this is just pi over 2. Okay, so k pi plus pi over 2. If you distribute the pi over 2 in here, you're going to end up with k pi plus pi over 2. So let's write that. K pi plus pi over 2. Okay. Okay, so this form is going to be a little more useful to us, especially for this type of example here. Now, really, you can use either form you want, but it's most of the time going to be better to use this form here, because you can simplify algebraically more easily with this form here. But anyway, moving on. So that's the original, so this is the equation for the vertical asymptotes for the original tangent function for y equals tangent of x. Okay, so this is for y equals tangent of just plain old x. Okay, but we don't have that, we have this more complicated mess here. So after we've written down the original equation, what we do then is say new, okay, new. Alright, so what we do, this is always what we do. We take, so for tangents, and actually it's the same thing for secants, because tangent and secant both have cosine in the denominator. Okay, so it's actually the same thing for tangent and secant. But what we do is we take the entire expression inside of the tangent. Okay, take the entire expression inside of the tangent, and then set it equal to k pi plus pi over 2. Okay, why do we do that? Because for the original, we have x equals k pi plus pi over 2. Why is it just x? Because x is the only thing in the tangent, okay? But for our new function, we have this entire mess inside of the tangent, okay? This entire mess is inside of the tangent. So we take that entire mess, and we set it equal to, so take the entire mess and set it equal to k pi plus pi over 2. Okay, so see the pattern there? Whatever is inside of the tangent function, we set that equal to k pi plus pi over 2. Okay, so see here, tangent of x equals k pi plus pi over 2. 2 times the tangent of this mess, minus 6, equals this mess, or sorry, not equals, if we want to find the vertical asymptotes, then we say this mess equals k pi plus pi over 2. Okay, so whatever is inside of the trig function, whether it's just x or an expression involving x, set whatever's inside of the trig function, set it equal to k pi plus pi over 2. Okay, that's what you do for tangents, and it's what you do for secants. But for cotangents and cosecants, it's different, and we'll talk about those in those videos. But anyway, for tangents and secants, you do exactly this. Set the entire expression inside of the trig function equal to k pi plus pi over 2. Okay? So notice this 2 out here affects absolutely nothing. It does not matter at all. This could be a 2, it could be a negative 2, it could be a 27.134, a negative 8. It does not matter what number's out here at all. Okay? This minus 6 doesn't matter either. Okay? It could be minus 6, minus 12, plus 14, anything. Okay? This minus 6 is just a vertical shift. Moves the graph up and down. So if you move up and down, that's not going to affect your vertical asymptotes. Likewise, this 2 just kind of stretches it vertically. Okay, so this just sort of affects the vertical stretching factor. So that's not going to change the vertical asymptotes at all. Okay, the only thing that matters is which trig function is it and what's inside of the trig function. Okay, because it's a tangent, we use k pi plus pi over 2. And then what we do is we take the entire expression inside of the tangent and set it equal to k pi plus pi over 2. Okay, so that's very important there. The whole thing inside of the trig function, set it equal to k pi plus pi over 2. Okay, so that's sort of step 1. Write down the original and then the new. Okay, then once we have this here, so 1/3 x plus pi over 2 equals k pi plus pi over 2. So now what we do is solve this equation for x. Okay, so let's write this again without the red box. So 1/3 x plus pi over 2 equals k pi plus pi over 2. Okay, so I'm just rewriting this without the red box because I want to leave this here for the parallelism. Okay, tangent of x, it's x equals k pi plus pi over 2, blah, blah, blah. Tangent of big mess, blah, blah, blah. Big mess equals k pi plus pi over 2. Okay, so again, whatever's inside of the tangent function or the secant function, set it equal to k pi plus pi over 2. Okay, and then once you've done that, now you solve that equation for x. Okay, so we'll zoom in a little bit here. Now notice we do have a k here. All right, and remember k just represents any integer, but we're going to stop writing that so we can save space and time. And we'll write it again at the end so we can be thorough. But anyway, so 1/3 x plus pi over 2 equals k pi plus pi over 2. So our answer is going to have a k in it. Okay, but anyway, what we do first is subtract pi over 2 from both sides. So then 1/3 x equals just k pi. Okay, because if we subtract pi over 2 from both sides, this is gone and this is gone. Okay, that's great. That's wonderful. Okay, that's also why this form right here is better, because if we left it in this form, it wouldn't really simplify that nicely until we expanded this. Okay, so we're going to end up expanding that anyway. So most of the time, it's better to use this form. So 1/3 x equals k pi, multiply both sides by 3. Okay, so then 3 times 1/3 just leaves us with 1 times x, and then k pi times 3, it's more common to write. So what we have now is just x on the left, okay, just x by itself on the left. And then here, 3k pi. It's a little more common. It doesn't really matter though. Some people might say 3 pi k, but it really doesn't matter. Okay, but now here, that's sort of the end. That's it can't really be simplified anymore. So 3k pi, where k is any integer. Okay, so we will write it again at the end. We just didn't want to write it at each step along the way. Okay, so that's the answer for part of the problem. Okay, so you know, these numbers worked out kind of nicely. This example wasn't that bad. We're also not done yet, right? Why are we not done yet? Is we have to find 5 specific equations of vertical asymptotes, okay? But anyway, just to recap what we've done so far, it might feel like we've done a lot because we've been talking a lot, but there's really not a whole lot has happened, okay? All we did is write the original equation of the asymptotes, which for tangent functions, you're always going to do that same thing in the beginning. We can just say x equals k pi plus pi over 2, okay? And then what you do is write new, okay, the equations of the vertical asymptotes for our new tangent function. Our new one is this, okay? The original one is just plain old tangent of x, okay? Untransformed, not shifted, stretched, or anything. But our new one is the one we were given, okay? And what we do is take the entire expression inside of the trig function, set it equal to k pi plus pi over 2. Okay? For tangents and secants, that's what you do. Okay, and then once you've done that, you solve the equation for x, you'll get an answer in terms of k, and this is your new general equation, okay? So that's part one, sort of, so to speak here. So example one, find the general equation for the vertical asymptotes of this guy here, and this is it, okay? This is the general equation right here. So x equals 3k pi, where k is any integer, that's it. And we saw it really wasn't that bad, right? Because the pi over 2's, they canceled, so that worked out pretty nicely, and then we just had to multiply by 3. So this really wasn't that bad. Now it might feel kind of weird because our answer, it's in terms of k, but it should be, right? Because we're just finding a general equation. Okay, just like x equals 2k plus 1 times pi over 2, where k is any integer. Just like that's a general equation representing infinitely many vertical asymptotes, so is this, okay? As well it should be, because if you take the tangent function and if you stretch it, shrink it, and move it around a little bit, it's still going to have infinitely many asymptotes, right? Just they're going to have a different general equation now, okay? And then what we're doing here is finding that, okay? So again, to find the general equation, all that matters is which trig function is it and what's inside of the trig function. Since it's a tangent, we use k pi plus pi over 2. And then what we do is we take the entire expression inside of the trig function and set it equal to k pi plus pi over 2, okay? So whether it's tangent, secant, cotangent, or cosecant, you always take the entire expression inside, okay? And what you use here, okay, what you use on this side of the equation, it depends on the trig function. For tangent and secant, use this. For cotangent and cosecant, well, you just use k pi, but we'll talk about that in those videos. All right, anyway, now how do we find 5 specific equations, okay? Well, all we do is plug in specific values of k. All right, so this gives us the general equation for all the vertical asymptotes. Now, what if we want to find specific ones? We just have to plug in values of k, all right? So basically, this tells us that the vertical asymptotes in general are given by this equation, x equals 3k pi, where k is any integer. So if we want to find a specific one, we'll just pick a value of k, and that's really all we have to do. Pick a value of k, plug it into here, and that's going to give us a specific vertical asymptote. Okay, so let's go ahead and do that. So we're kind of out of room here, so let's erase this part here. Okay, we'll erase this word here. And we'll erase this whole thing here. Okay, so here is our general equation. So what we're going to do is take this general equation now. Okay, take the general equation. Actually, we're going to make a little chart here with 2 columns. So one column is going to say k. And we want to find 5 specific equations. So what we have to do then is plug in 5 specific values of k, okay, separately. So plug in one value of k, we get one specific equation. Plug in another one, get another specific equation. So we have to do that 5 times. So we can pick any 5 values of k that we want, any 5 integer values. K represents any integer, so we can pick literally any 5 integers we want. But it's sort of custom to stay around 0 or around numbers that would make this easy to evaluate. 3k pi is not terribly complicated. 0 is definitely a good value of k to use here, so let's stick around that. So since we have to do 5 of them, let's say -2, -1, 0, 1, and 2. Okay, those are 5 good values to use. Although really anything would be not terrible. So k, and then we'll label this column VA for vertical asymptote. So if k is -2, what's the corresponding vertical asymptote? Well, if k is -2, then x is going to be 3 times k, which is -2, times pi, okay, which is -6 pi. Okay, 3 times -2 times pi, which is -6 pi. So if k specifically is -2, then the corresponding vertical asymptote is x equals -6 pi. Okay, and be very careful if you're answering a question like this for homework or for a quiz or a test, make sure you say x equals -6 pi or x equals whatever it is. Okay, because it is a vertical asymptote, so you have to give the equation, you have to actually give it as an equation of a vertical line. Okay, so it's not enough to just say -6 pi. Okay, you're talking about a vertical line, so you want to make sure that you answer as an equation of a vertical line. Okay, so x equals -6 pi, that's the equation of a vertical line. -6 pi by itself is not really enough, so you do want to be careful about that. Okay, what if k is -1? Well, then x will be 3 times k, which is -1, times pi, which is just -3 pi. Okay, so if x is -1, then you have x equals -3 pi. Okay. What if k is 0? Then x equals 3 times 0 times pi, which is just going to be 0, right? So 3 times 0 is 0, 0 times pi is 0, so the whole thing is just 0. So x equals 0 is a vertical asymptote there. Okay, so that's nice. What if k is 1? Then x equals 3 times 1 times pi, which is just plain old 3 pi. Okay. So yes, this algebra is relatively simple, and we probably don't have to show all the details, but there's no harm in it, especially for introducing a new concept. So for the vertical asymptote for k equals 2, so what happens when k is 2? Well, then we have x equals 3 times 2 times pi. So 3 times 2 times pi. So that's just going to be 6 pi. Okay. 6 pi. Okay, so that's the answer to the other part of the problem here. Find 5 specific equations of vertical asymptotes, and here they are. Okay, x equals negative 6 pi, x equals negative 3 pi, x equals 0, x equals positive 3 pi, x equals positive 6 pi. Okay, so here is the general equation that we found earlier, and then we use this general equation to get 5 specific equations of vertical asymptotes. And so let's just recap everything we did. So we kind of erased it, but what we did at the beginning was we said, okay, the original equation of the asymptotes was x equals k pi plus pi over 2. Okay, k pi plus pi over 2. So that's just for plain old tangent of x. So the new one, okay, so this is the original one. Original. And then the new one is take the entire expression inside of here, so 1/3 x plus pi over 2, and then set it equal to the same thing, k pi plus pi over 2. Oops. K pi plus pi over 2. Okay, so that's what we do in the very beginning. So always for tangents and secants, always do that. The original is going to be this, and then you say new one, whatever's inside of the trig function, set that entire expression inside of the trig function equal to k pi plus pi over 2, solve for x, blah blah blah, we get x equals 3k pi, where k is any integer, so that's our general equation. Okay, and then we use the general equation to find 5 specific equations by choosing any 5 specific integer values of k. And since this is 3k pi, it's good to stick around 0, but really you could have used any 5 specific k, values of k that you wanted. Okay, we could have used negative 200, negative 100, 10,000, 1,011, 273. Anything we wanted really, any 5 specific integers, but it's good to keep it simple if you can, why not? Okay, so anyway, that's really it for example 1, and a few more examples coming up for cotangent and secant and cosecant as well. And we'll skip some of the details that we talked about here. Anyway, a few more examples coming up, and this is how to find vertical asymptotes for a general tangent function.